Okay, here's a short walkthrough on a couple of examples on lesson number 8, simplifying radicals. I'm going to pick two questions on the back of the sheet that we didn't do, and those are questions 32 and 34. I've already rewritten them on a separate page, so I'll walk you through them. 32 says the square root of 96 a to the fourth. Now, I know how to break down a to the fourth, but I'm going to have to worry about that 96 anyway. So here's what we have to do. In order to break down the 96, we need to factor it into something that includes a perfect square. Now, perfect squares are these numbers. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, then we have 6 squared is 36, 49, 64, 81, 100, and for the purpose of this video, we'll stop there. They keep going. I want to see which one of these divides into 96. So I'll show you how I do that on a calculator, and this will work on any calculator, not just like a special fancy graphing calculator. Alright. I want to see which one of these divides evenly into 96. So let's see, 96 divided by 4. That works. Let's see if any bigger ones work in, because bigger is better as far as factoring goes. I want the biggest one. So 96 divided by 9. No, that doesn't work. 96 divided by 16. Well, that works really well. 16 times 6. And you can keep going if you're not sure if that's the biggest one. You can keep trying, but 16 is. 16 times 6. So I'm going to rewrite 96 as 16 times 6, and now I can break down the a to the fourth. I want to break these guys up into pairs, 2's, so I'm going to change the a to the fourth into an a squared. Now this 16 here can be rewritten as 4 squared. So I'll rewrite everything. 4 squared times 6 times a squared times a squared. And now the analogy that I used is this square root here is kind of like the bouncer at a club. He's not going to let you in unless you have the right invite. What kind of an invitation is he looking for? He's looking for squares. So you hand over your invite, and then you're allowed to go to the outside. You're allowed to go through. You're allowed to exit the line. Now a squared here has one as well, so he hands it over. And this a squared has one as well. The guy that gets stuck underneath is this guy, the 6. He's stuck, so he's still going to be underneath the radical. But what I'm going to have on the outside is going to be a 4. He got into the club. And an a. And another a. I can simplify this into 4a squared, square root of 6. One more a little bit quicker. 34. 72 can be broken up into the perfect square 36 times 2. M squared becomes, or rather m to the fourth becomes m squared times m squared. So still got 4 m's. The n is going to become n squared and n squared. Square root all that. So like this became that, this became that, and this became that. I'm going to rewrite it because 36 is just 6 squared times 2 times m squared, n squared, and the big square root over it. Now square root is the bouncer. He's looking for invitations again. Who has an invite? This guy does. Hand over the invite, and he can go outside. This guy does, so does this guy does, and this guy does. Now this 2 here, it stinks to be him because he doesn't have an invitation, he doesn't get to go through. So who does get to go through? The 6, 2 m's, and 2 n's. So it looks a little messy, let's clean that up. 6, m, n, and the only guy stuck underneath is the 2. I can simplify this. M and m is m squared, so 6m squared. N squared, square root of 2. And that's the end of the questions. If you have any more questions, please feel free to contact me. But yeah, it's a pretty quick little topic. Good luck. Remember that we have a quiz coming up. If you're watching this video today or tomorrow, then you have a quiz coming up. If you're watching this video sometime in the future, then enjoy your review.